30, I know that sine, according to SOHCAHTOA, sine is equal to opposite over hypotenuse. In terms of 30 degrees, that is 1 opposite over hypotenuse. So I'm going to get 1 over 2 plus cos of 60, and we know cos is adjacent, which is also 1 in terms of 60 over 2. Okay, and I know that a half plus a half is just going to give me 1. There we go. All right, in this next one over here, they want us to take sine of 45 and multiply it by cos of 45. So we're going to go to our 45-degree angle, or 45-degree triangle, and we're going to label 45 degrees. This is going to be my adjacent, this is my opposite, and this is my hypotenuse. All right, so sine of 45 degrees, sine is opposite over hypotenuse. That's going to be 1 over root 2 times cos is adjacent over hypotenuse, which is also 1 over root 2. Okay, and then how do I multiply fractions? Just multiply the top at the top and the bottom at the bottom. So 1 times 1 will give me 1 at the top, and then square root 2 times square root 2 is the same thing as the square root of 2 squared. And I know that the squared and the square root will get rid of each other because they're inverses of each other. So what I actually have down here is 2. So my answer is 1 over 2. All right, so let's look at tan of 30 degrees. Again, 30 degrees is labeled in green. So I know tan, according to SOHCAHTOA, is opposite over adjacent. So that's going to give me 1 over root 3, 1 over square root 3, times sine of 60. So sine of 60 is going to be opposite over hypotenuse. So the opposite over here is root 3 over 2. And again, when we multiply fractions, top, top, bottom, bottom. All right, so 1 times root 3 will give me root 3. And at the bottom, root 3 times 2 will give me 2 times root 3, or 2 root 3. All right, the root 3's will cancel. So my final answer is actually just a half. That's the final answer I would get. All right. Okay, so the last one over here takes a little bit more work, but I'm going to try and go at it a little bit fast because what we're doing is just doing the same thing over and over again. All right, cos of 30 degrees, cos is adjacent over hypotenuse. So that is going to give me root of 3 over 2 times sine of 60, which is opposite over hypotenuse. That's also root of 3 over 2, plus sine of 30 is 1 over 2, opposite over hypotenuse, 1 over 2, times cos of 60, which is also 1 over 2. All right, and we're multiplying, peeps. So multiply top with top, bottom with bottom, same here, top, top, bottom, bottom. So in the first one, root 3 times root 3 will just give us 3 over 4, plus 1 times 1 will give us 1, and at the bottom, 2 times 2 will give us 4. And 3/4 plus a quarter will just give us 1. So that's the final answer that we get there. All right, with that being said, welcome everybody to MathsLive. I hope everybody is doing well. I've gotten 2 good afternoons, one from Desmarie and one from Buikanyo. I hope everybody else is doing well. If you're joining us for the very first time, please let us know in the chat so that we can welcome you to MathsLive. I see a couple of new names that I haven't seen before. So I'm thinking we do have some new people joining us. Well, in that case, welcome. Hello, Kanyo. Hello. Yes, there's somebody named Vivo. I don't know if that's your actual name, my darling, or if that's the name of your phone. Welcome to MathsLive. Can I change your name to anything? You can just pop your name in the chat for me. Hello, Peño. Lovely. Okay, I'm going to change your name to Peño. Let's welcome Peño, everybody, on this very cold Monday. I agree with you, Kanyo. It is very, very cold. Hi, Peño. Welcome to MathsLive. It's so great to have you with us. Somebody else also named Samsung. Hello, Leah. Leah's also joining us for the first time. Hello, Leah. Welcome to the best maths class you've ever joined your entire life. Lovely to have you with us. Oh, see, I'm not sure what you mean when you say, what about us? Why do you always welcome grade 10s? Who must I welcome? I don't know who else to welcome. So I'm sorry, Sia. Tell me what to do and I'll do it right. I promise. Okay. Oh, lovely to see the welcoming party in the chat. Lovely to see it. Okay, shall we get into today's lesson? Esteemed human beings. Hi, Michael Jackson. I'm already loving it. Guys, is this the famous Michael Jackson that I've been so greatly told about? Is this the Michael Jackson himself? Michael Jackson, if you were with Watobi in grade 9, your reputation precedes you. Oh, if you were with us in grade 9, then welcome. Clearly, we've heard of you before. You're clearly a celebrity up in these streets. So I'm very, very honored to welcome you to MathsLive. It's great to have you with us. All right, guys, let's get into today's lesson. All right, so today what we're going to be doing is we're going to be taking the idea of right-angled triangles and we're going to be putting them on a Cartesian plane. Now, we've all seen a Cartesian plane before, right? We know that this over here is our x-axis, this over here is our y, this over here, negative x, and down here we've got negative y. Now, the idea behind taking this trigonometry and kind of putting it on a Cartesian plane is to get around the idea of coordinate geometry. Sorry. So if you think about it, have you guys ever seen, like, I don't know if you've seen a movie where people are traveling like in a ship or on a plane, and then you see they have like a screen where there's like black lines like this, like, or the lines are green, and then there's like a tiny little moving object. It's like a dot, D, and then it's moving because the plane is moving or something along those lines. Have we seen that before? It's like, you know, in all these spy action movies. Yes. Yes, yeah. It's like in these action movies where they're like, don't shoot them down and that kind of thing. Yes. Okay, so the idea behind coordinate geometry is exactly what we're going to be looking at right now. So when you hear these people talk about things like these people are at 700 or 72.3 degrees this way and 44 point whatever, all of that actually stems around the idea that we can actually measure degrees around a coordinate plane. Hi, Mandisa. Lovely to have you. Lovely to see you again. So all of these can actually be seen on a Cartesian plane. So let's say we know for a fact that if I put a dot, let's say, for instance, I put a dot over here, right? And these are the coordinates 12 and 5, right? Hello, Vanessa. Oh, it's so great to see you guys with us today. Okay, so we know that these are coordinates. What does this 12 stand for? What is this 12, the what coordinate? What does the 12 actually mean, the what coordinate?
That it belongs on the x-axis.
Absolutely, yes, that's good. This is the x-axis, thank you, Sia. Right, and this 5 over here would be then our y-axis, right? Now, if we look at this, anything that we're actually trying to track, even on a GPS, is relative to a point in time. So even if you're driving in your car and you know that lovely lady on Google is telling you in 400 meters, turn left, and she never tells you to turn left at the right place and then you miss your exit. You know that lady, she's always using some sort of reference. So it's when we say that this coordinate is 12 and 5, we're saying that it's 12 and 5 according to a reference point. And that reference point we're always looking at is our origin. It's always this point 0, 0. Okay, so when we say that this thing is 12x and 5y, what we're saying is it is 12 paces in the x direction and 5 paces in the y direction in relation to this point. It is 12 paces away from the origin in the x direction and 5 paces away from the origin in the y direction. Give me a thumbs up. Are you guys understanding what ma'am is saying? Everyone okay with what I'm explaining? Excellent. Cool stuff. All right, so now what we're going to do is, it's always the for now for me. Okay, so now what we're going to do is, we're going to use what we know. We're going to say, all right, we know that this is some distance apart, right, from our origin. We're going to use, if you do physics, you'll know, you will have heard of vectors, right? So we could use like a vector system here. But thanks to our trusted old friend Pythagoras, which we had learned about, we know that if we want to measure the distance from here to there, we'll call this distance r, and I'll explain why it's r in just a second. We know that we can look at how far this thing has gone in this direction, how far our coordinate has gone in the x direction. We know that's going to be 12 units. Because in the x direction, we moved all the way up to 12. And from here, how many units did it move up? 5 units up. 5 units up. So I now know that if I want to measure that distance over there, I can just make this into a right-angled triangle, right? And then what can I use to find r? Which formula did we learn about the very first time? I'll give you a hint. It's not SOHCAHTOA. SOHCAHTOA is not going to be able to help us here because we do not have an angle. We don't have an angle. So other than SOHCAHTOA, what can we actually use to figure out what r is equal to?
Then can we use Pythagoras?
Yes, absolutely. I heard that, Sia. I heard that, Mandisa, 100%. We're going to use Pythagoras. So in this case, well done, Tadolwe, too. Beautiful. So in this case, we know that we're going to use Pythagoras to find r. So I'm going to give you guys a second. Please use Pythag. Find me the distance of r in the chat and just pop your answer in the chat for me. It's not rocket science, guys. It's just Pythagoras. So I'm going to give you guys a second. Give me an answer there for r. Okay.
Ma'am, r is equal to 13.
Beautiful. Thank you very much, Sia. 100% r is equal to 13. I'm not going to belabor this. We're going to go r is equal to the square root of 12 squared plus 5 squared. I know that 12 squared is 144 plus 25 is the square root of 169. Therefore, r is equal to 13. Now, I want us to note that this still tells us something about the coordinate, but this r value doesn't actually have anything to do with the coordinates themselves. The r value is actually the distance from 0 to that point xy. So this 13 means that if I wanted to travel straight from the point to there where that 12.5 or the coordinate is, then I have to travel, if I travel straight on a straight line, I'm going to travel 13 paces, like 13 meters or 13 kilometers, even though if I were to travel the long way around, I would go 12 and then I would go 5. So the 13 is just the long way. So I want us to note that it doesn't matter where r is sitting. R is always a distance. And distances can never be negative. I'm going to explain in just a bit as we go along. Now, let's explain that little part where they start talking about degrees and stuff. What we're going to do is we're going to look at the x coordinate over here as our 0 degrees. So we're going to pretend that we're actually putting this on a protractor. You know that round protractor that we usually get, like you can get that 360 kind of protractor, right? We're going to take this positive x values over here. This part over here, we're going to name that 0. That's 0 degrees. And then we're going to start measuring around any point in degrees going in that direction. So we're going to pretend, okay, so if we hit here, this part over here, we know that this is 90 degrees. So the y coordinate over here is going to be 90 degrees. If we keep coming around the corner, what is this negative x value going to be here? What is the degrees of this negative x value?
Is it 180?
It is 100% 180. This is a straight line. Good. So this is 180 degrees. If we keep going, when we get here, what happens? How much do we get over here?
270.
270. Beautiful. Thank you, Palesa and Sia, 100%. And then we come all the way around to a revolution, and the revolution, 100%. That's it, will be 360, or we'd be back at 0 degrees. So again, when you're watching all of these Mission Impossibles and whatever, and you see that little thing going around like deet, deet, and it's tracking something, you can think of it almost as this trigonometric plane that we're looking at over here, where we are, look at now what I've done. Okay, where we are literally tracking a point in terms of its distance from where, let's say, for instance, it's one plane versus another. We're looking at how far away is this plane from us, and also in what angle is it? If we are over here and the other plane is over there, at what degrees does this thing travel? Like that. We want to figure out what this angle over here is going to be. And we know that if we're looking for an angle, we can always name that angle theta. Okay, and Morangi, you're absolutely correct. Tom Cruise definitely loves maths. And unfortunately for us, if you want to be, if you want to join the FBI or the CIA, because it is an actual job, people do get picked to be part of the FBI and the CIA and the M6 and your Interpol, like all those cool movie stunt people, they do exist. You have to be really good at math to be able to do those jobs, because they require you to do things like this on your own, like tracking people and things like that, which is pretty cool, I think. So if any of you ever want to try out for, you know, special forces, yeah, like the CSI, things like that. Yeah, absolutely. You have to be really good at math. All right, excellent. So we've now got the whole map of what we're doing. Now we need to figure out what the degrees are. But hold on. If I want to now find the angle, I still know that this from here to there to there, this is a 90-degree angle. So how am I going to find my angle? Who can remember? What am I going to use in order to find my angle?
SOHCAHTOA.
SOHCAHTOA, absolutely. But specifically, what do we need to do to find an angle, Sia? Who remembers? It is SOHCAHTOA, 100% it's SOHCAHTOA. But because we're looking for an angle, what do we need to do?
Don't we need to look for the reciprocals?
Reciprocals, or what do we need to click? I'm wondering if anybody remembers. You're absolutely correct, Kanya, 100%. What do we need to click on our calculator in order to find an angle? I can't believe you guys forgot my hashtag. Oh no. Did we already forget? When we're looking for an angle, what must we do? We must click shift. Do not forget to click shift, guys. We're looking for an angle. Okay. Did you say that? I'm sorry, my darling. Yes, the reciprocal, which means shift. Yes, I'm sorry, my darling. I didn't quite hear you that clearly, but yes, you're 100% on point. Well done, Kanya. Yes. Okay, we need to click shift. And then again, guys, we need to label, as always, because labeling is always going to come up. According to my angle over here, there's 12 units over here. This is my adjacent side, right? That side all the way over there, that 5 over there, that's my opposite side, and my r over here is my hypotenuse. Now, we can use any of them to find the answer we're looking for. Let's look at what we have. All right, if I look at what I have, I've got my opposite, I've got my adjacent, I've got my hypotenuse. I've got all three. And what I want is my angle theta, right? So which one of them uses OA and OH and AH? They all do. So I want you guys to please use any of these. You can either use the sine, the cos, the tan. Find me the angle theta, please. Pop your answer in the chat when you're ready.
Ma'am,
Yes.
please repeat what you said we have to do.
Okay, you need to find the angle theta, please. Okay, so you can use either SOH, CAH, or TOA. That's completely up to you. Okay, I'll give you guys 2 more minutes. Don't think it's that difficult. All right, peeps, let's have a look at this answer quickly.
I got 22.62.
22.62. All right. Okay, we're going to corroborate your story in just a second, sir. All right, 22.62. All right, let's see if that's true. Okay, so remember you can use any of the ratios. Good, Penyo, excellent work. All right. So if I choose to use O and H, that means I'm using sine, right? So I can do this. I can go sine of theta is equal to opposite over hypotenuse. Now the theta part of it is going to be equal to shift sine or arc sine of opposite, which is 5 over 13. Right. Now, if I decide to use cos, if I decide to use adjacent and hypotenuse, then I'm going to have cos of theta is equal to adjacent over hypotenuse. Therefore, theta is equal to arc cos, so shift of cos of adjacent, which is 12, over hypotenuse, which is 13. Again, I can also choose to use tan, because if I choose to use opposite and adjacent, then I can use tan of theta is equal to opposite over adjacent. Therefore, theta is equal to arctan or shift tan of opposite, which is 5 over adjacent, which is 12. Now, you'll find most likely that it doesn't matter which one of these three you use. If you punch in sine, if you punch in cos, if you punch in tan, you're going to end up with the same answer for all three, right? So shift sine, I'm going to use the shift sine one. It doesn't matter. Arc sine of 5 over 13 is equal to 22.62. Correct. Therefore, our angle is equal to 22.62 degrees. Okay, don't forget the degrees because it is an angle. We are measuring an angle. All right, I just want to gauge with everyone before I actually dive into some other questions. On a scale of 1 to 10, 1 being, ma'am, hi, Anyege, come and fetch me, and 10 being, I'm fine, ma'am, I'm going to be able to do these by myself. Where are we sitting? Give me a scale. 1 being, I don't know anything. 10 being, I know this, I've got it. Okay, Michael, that's fair. That's fair. We are going to do a couple more examples to see if we understand. Okay, 4.5, 6, 7-ish. All right, so can we look at what a typical example would look like? Okay, let's start by doing a little bit of practice. Okay, so I've got a Cartesian plane over here. That's a good amount to be at Penny. That just means you need practice. Okay, so I'm going to ask you guys to use these coordinates. These are coordinates on our Cartesian plane. You guys need to put them on the Cartesian plane. I'm actually going to scratch out this last one because I just used that last one as an example. So we don't need that one. We're going to do these three, put them on the Cartesian plane, and I want you guys to use either sine or cos or tan to find me the angle that each of these makes with the origin. Okay, I'll take it slowly. So if we look at this first one, let's name this one number one. If you look at number one, if I had to plot 7 and 7, 1, 2, 3, 4, 5, 6, 7. So I'm going to go up again. Okay, so there is my coordinate 7, 7. Right, I know that the shortest distance, just as a vector, from here to there, would be from the origin in a straight line, like that. Okay, what I do know, however, is if I had to use the X and Y plane, I know that I can make this a right angle triangle. I know I've traveled 7 units in this direction, and I've also traveled 7 units in that direction. I want my angle theta. And I know that if I want to find r over here, which is the radius, because that thing that we're actually looking at that goes around is called a radar, as in a radius. So we know that this radius, this arm, actually goes all the way around my circle. It's almost like we've put a pencil in the middle and we're drawing a circle all the way around. That's why we call it r, for radius. So what you guys need to do for me is you need to find me the distance r, you need to find me what r is equal to, and you need to find me the angle theta for all three of these. R equals, theta equals, r equals, theta equals. I just want to gauge. Give me a thumbs up in the chat if you understand what you need to do. Thumbs down if you'd like me to help you. How are we feeling, guys? Okay, Oko says you've got it. Cool stuff. Michael's got it. Bikanyo's got it. Beautiful. Thanks, Mandisa. All right, I'm not getting any protests, so I'm gonna give you guys a few minutes. Okay, go ahead and find me those 6 elements. Pop your favorite emoji in the chat. I don't really have a favorite emoji today. I'm gonna pick a random one. Ooh, let me pick this one. I'm gonna slay because I actually did get my nails did, and I've been feeling myself. I've been walking around like a slay queen. Yes, Morangi, what's up?
Ma'am, I wanted to ask, when we finding beta, do we do it for like all like for sin, cos, and tan?
No, you just have to find one because that's all you really
Oh,
need. All of them are going to give you
oh,
the same answer, so you can pick sine, cos, or tan.
all right,
Okay.
ma'am.
All right. Leah, if that's for the first question, yes, 100% correct. Yes, you should get that. Now, don't forget to do the other ones as well. So you need to do this one. So it's not just that one. Number 1, number 2, and number 3. Okay, you need to do it for all 3 of them. And remember, you must also find R, which is the hypotenuse, basically. I'll give everybody 2 more minutes and then we'll start discussing. One more minute, guys. I think less than a minute. All right, peeps, that's time. Let's have a look at these answers. It's okay if we didn't finish. Yeah, we'll get to it in just a bit. All right, so let's go ahead and talk about this first one over here. Now, I know if in order to find R, I'm going to have to use Pythagoras. So I know R is going to give me the square root of 7 squared plus 7 squared. R is therefore going to equal to 7 squared plus 7 squared should be something like 4,61. 4,61. Or am I lying, guys? Ooh, I found the cube root instead of the square root. My bad. Plus 7 squared. 7 root 2. I figured it should have been something with a 7 in it. All right, so this becomes 7 root 2. That is the distance there. 7 root 2. And to find theta, I can use either sine, cos, or tan. I'm going to use tan because it's just easier. Arctan of 7 over 7, which is equal to, yes.
Ma'am, over there, when you put 7 root 2, is it okay if you set the answer?
You mean like Desmarie did, like 9,89?
Yes.
Okay. I'm going to advise against it. Like, you're not wrong. And some teachers might be gracious enough to not mark you wrong. Unfortunately, in my class, I'm going to mark you wrong. Okay. The most accurate answer that we can possibly get is the one that the calculator gives us. Okay. So even if, let's say, for instance, the calculator gives you 1 over 3 as a fraction, you are not meant to write 0,333. This is actually like you cutting off this. So instead of just writing 9,89, I'd rather you leave it as 7 root 2. Okay, that's the most accurate answer. Am I
Okay,
making
ma'am.
sense? Unless the
Yes.
calculator gives you decimals, then write the decimals down. But if your calculator doesn't give you decimals and it gives you an answer like this, or it gives you a fraction, write down the answer the calculator gives you.
Okay,
Okay.
ma'am.
All right, good stuff. All right, Desmarie, I hope that answers your question as well, because I think you also got the same thing. Okay. So shift tan or arc tan of 7/7 is going to give us 45 degrees. Okay, now we're going to do the same over here for 2. Again, if I put this on the Cartesian plane, everything is going to shift around a little bit, right? If I put this on the Cartesian plane, I'm going to move 6 in the R direction or in the X direction and 3 in the Y. 3 units this way, 6 units that way, and I'm going to look for that distance there. Right, and that is now R, and then I know that I need to find the length of R and I need to find theta. So in order to find R, again, R is equal to the square root of 6 squared plus 3 squared, which is equal to 36 plus 9 is 3 root 5. Okay. Yes, 36 plus 9 would be 45, right? Would be the square root of 45. And I can take a 9 out there, so that becomes 3 root 5. Yeah, 3 root 5, correct. Okay, so the radius of this one is 3 square root 5. And then if we want to find the theta, again, I'm also going to use arctan again, because that's the information they've given me. They've given me the opposite and the adjacent. That's going to be theta of 3/6. Now, this time, your calculator will give you decimals, so make sure that you write down the decimals in this particular case. So in this case, the answer we're going to use is 26,57 degrees. Because that's the answer the calculator gives us. All right, then we're going to do this last one over here. If we calculate for the radius over here, we're going to find that if we use Pythagoras, the radius we're going to get is 5 for this one over here. And then in order to find that, again, I'm going to use arctan. Not root 5. Not root 5, Buikanyo, just 5. Okay, it should just be 5, not root 5. Of 4/3, and my calculator will give me the answer, 53,13 degrees. All right, 1, 2, 3, 4, 5, 6. Tell me in the chat, how much did we get out of 6? Let me know how this went. You got 6. Nicely done.
Yes.
Very nice. Very nice. Okay, and this is just the start of the complications before they start. That's okay, Penyo. I hope you know where we didn't quite get that 1 extra mark there. Okay, and remember, this is the place where we make mistakes. We learn from them now so that we don't make them in exams and tests. So that's perfectly fine. Mandisa, my darling, are we sure we understand why we didn't quite get it? I don't want you guys to say that I got 4 and 5 and you don't know why you got 5 or why you got 4. Okay.
Ma'am, I messed up the first equation.
Okay. Oh, that's okay, my darling. As long as we're learning from it. Michael Jackson, what happened? What happened, Michael? Okay, you and I need to talk. If we're not very good at this, then you need to ask me as many questions as possible as we go. All right. Okay, let's talk a little bit more strategically here. This is what questions normally look like in an exam paper. So they don't really tell us much information. They give us a coordinate, they give us theta. So in this case, they want us to calculate for theta, right? Are we able to use the information we've been given in on this particular coordinate plane and give us an answer? That's okay, Penyo. That's okay, my darling. You can use cos as long as you end up with the same answer. Thank you, Sia. All right. Can I ask everybody to use the information that we've got on the screen to find me theta? Are we able to do that? All right, excellent. I'm going to give you guys 2 minutes. It shouldn't take us that long. Remember, we know that this is our x coordinate and this over here is our y coordinate, which means we traveled however many units in the x direction, and we traveled however many units in the y direction. So look at that and then give me an answer when you're ready. Thank you, Sia. That's the right attitude. We're finding theta, Desmarie. We're finding theta using the information we've been given. Mandisa's done. How's everyone else doing? Cool, Leah. Nice one. We've got less than a minute, everyone else. Beautiful. Well done. Nice one, Palisa. Nice Peño. All right, there we go. There's time. Okay, again, so we know that according to this triangle that we've got over here, we're going to travel 5 units in this direction, and we're going to travel 8 units in that direction. And I know that if I label in terms of my angle theta, this over here is my adjacent side, and that over there is my opposite side. I technically don't really need my hypotenuse, but in the coming questions, we're definitely going to need them here. I know I have the opposite and I have the adjacent, and I want my angle theta. Therefore, I'm going to click shift because I need an angle. I must shift angle. So I'm going to use tan of theta because I've got the opposite over the adjacent. Therefore, theta is going to equal to arctan of the opposite, which is 8, over adjacent, which is 5. And that would give me an answer of 58 degrees. I'm just going to round up. 58 degrees. That is theta over there. All right. So not that difficult a question. We're just gauging the information that we have so far. All right. Let's look at the next one. Okay. I want us to note something in this particular question. I want us to note that everything has been shifted in that direction. So our angle is no longer an acute angle. It is an obtuse angle. Yes? Because it's larger than 90 degrees and it's less than 100. Hello? Oko, if that was you, my darling, can I ask you to put your hand up for me so that we can unmute again and just see what you were asking, because I didn't hear that at all. It was terrible. I'm sorry, my darling. Let's see if we can communicate a little bit better. Okay, do you want to unmute? Hello? Sure. Okay, I can't quite hear you, my darling. You're breaking up. Can I ask you to type your question in the chat for me, please? Okay, because I can't hear you at all. Sit next to your Wi-Fi. Yes, they are, Michael. They are on our YouTube channel. Okay, Oko, if you could just mute yourself for me. All right, so here's the thing, guys. In this particular question over here, I'm going to ask you guys to do a few things for me. First thing is we're going to find theta. We're first going to find theta. Or let's rather do this. Let's say we want to find r. First, we're going to find r. From finding r, we're going to find the sine of theta. And then we're going to find the cos of theta. And then step number 4 is we're actually going to find theta. Now, I want us to be very careful with the difference. Not quite, Oko, because the answer that we got over here was actually 57,99. That's the answer that I'm getting. Unless you used like cos or sine, but most of them should be close enough to 58 degrees for it to work. So the 0.27 seems a bit misleading to me, my darling. Okay, maybe have a look again. Okay.
Ma'am,
Yes.
you're saying that if you used sin or cos, your number wouldn't your answer wouldn't be the same as what you got, but in the 50s.
It should be very close to 58, like 57 point something.
Okay.
High, like 57 point something high. Yes?
Yes, ma'am.
Yeah. So it should be close enough to 58 for us to be like, okay, yeah, there's a margin of error, obviously, because of the decimals that go into finding R, which is perfectly fine, which is why I don't advocate for decimals to begin with, because they give us inaccuracies like that. All right. So I want
Yeah.
us to be very careful. We're going to be, yes, my darling.
Sorry. When they give you a graph, which one would you know how to use between sin, cos, and tan?
You don't, my darling. So remember when we do that whole what do I want, what do I have versus what I want?
Yes, ma'am.
That's what's going to inform which one of them you use. Okay, I'm going to show you another exam-like question in the next lesson, just so you can see how they ask the question, because half the time they don't even give us this. Like they don't give us the drawing, they just give us the coordinate, and then you must figure out the drawing. Okay, so it depends on what they want.
Okay, thank you.
I'll show you as we go along. Don't stress. Okay, let's start over here. Now, I want you guys to remember that in number 4 over here, when they ask you for theta, they're actually asking you to find the angle. Now, in the questions before, let me just not do that. In the questions before over here, when they ask for sine of theta and cos of theta, what I'm actually asking for is for the ratio. So the sine of theta is going to be something over something. That's what the sine of theta is going to be. Same with cos of theta. That's going to be something over something. That's the answer we're going to get. But for theta, we are actually going to find an angle. All right. So I want you guys to give this question a try. This is the last question we're going to do today. We are a bit out of time, but I think we've got the gist of what they really want from us in this case. All right,
Should we
find
shift
me
angle?
these 4 and pop your answer in the chat. Yes, Sia.
Should we shift angle?
Yeah, for the last one, of course you must, because when we ask for theta, what does theta stand for? Theta stands for an angle, right? So in order to find the angle, I must shift angle. Okay. Cool, guys. I'm going to give you guys 3 minutes because we are running out of time. Two more minutes, guys. No, Balisa, no, my darling, no, we shouldn't. Okay, because in those questions, they don't want the angle. They don't want the angle. Only in the last question do they want the angle. Okay, so that's when you click shift. In the other two, they just want you to use SOHCAHTOA. So tell them what sine of the angle is. Tell them what sine of theta according to SOHCAHTOA is. So something over something. That's why I'm saying my answer will be a number over another number for 2 and 3. Okay. Good stuff. All right, I'm going to have to get into the answer over here, guys. Now, I want us to note something over here, guys, that just because our x value is -3, that doesn't mean that I've walked in the negative direction. No, it just means I've walked 3 directions in the negative x direction. It doesn't mean that I've actually walked -3 kilometers or -3 meters. All it means is I've walked 3 units in the negative x direction. That's what this -3 means. And I've come up 4 units in the y direction. Okay, that's all. Now, if I calculate for r over here, I'm going to get the square root of 4 squared plus 3 squared. Oh, I'm lying. It's going to give me the square root of -3 all squared plus 4 squared, which is then going to give me -3 all squared will give me +9 plus 16, which is 25. So my R must equal 5 units. So R is equal to 5 units. And remember, R can never be negative. It's a distance. Right. Now, if they ask us for sine of theta, I've got all of them. I know that this is my angle. So I'm going to use this inside over here as my reference angle because I need to use the angle inside the triangle. Right, so if this is my reference angle over here, this is going to be my adjacent side, that is going to be my opposite side, and this is going to be my hypotenuse. Now, if I want to write sine of theta is opposite, which is 4 over hypotenuse, which is 5. So 4 over 5. Now, here's the tricky part. For cos, because cos is moving in this direction, right, the adjacent is moving in that direction, it's not just 3 over the hypotenuse of 5, we know that it's moving in that direction, so it's going to be -3 over 5. Okay, so our x value or our adjacent side over here actually has a distance of -3. It's moving in the negative direction. Now, in order to find theta, you can either use sine, cos, or tan. It won't make a difference. I'm going to use arctan of 4 over 3. If I put 4 over -3 into my calculator, shift tan of 4 over -3, it should give me the larger angle. Or no, it should give me the negative angle. Actually, it won't. It will give me the negative angle. So it's going to give me -53,13 degrees. Now, the issue with that negative is that what they've actually given us is this angle here on the inside. So if we want to find the larger angle, we're just going to take this 53,13 and we're going to subtract it from 180 degrees. Okay, so we're going to take, this is equal to 180 degrees minus 53,13 degrees. Let me see. And the answer we're looking for is actually 126,87 degrees, 87 degrees. And that's this angle on the outside over here. This one here, 126,87 degrees. That's the one we're looking at. All right. Okay, peeps, we are out of time.